All right, I'm gonna get started. So thank you all for being here with us today. Let me turn on my video. Hi, thanks all for joining. So my name is Elisa Oberholzer, and I'm a Senior Associate of Research with the Clean Cooking Alliance. So you might have heard that this week is a very exciting week for us here at the Alliance. We're hosting the first ever Week of Clean Cooking, which is featuring a series of virtual engagements, events, and content releases and networking opportunities to catalyze action across the clean cooking sector. And this, I believe, is the last virtual event of the week. And so real quick, I'd like to go over some housekeeping items first. So Santiago, do you want to switch the slide? Okay, so firstly, all participants are muted. And then if you have questions, you can use the Q&A feature to ask any questions, and we'll answer these questions during the dedicated Q&A time. And then if for some reason you're experiencing technical difficulties, you can just write a message into the Q&A feature as well, and my colleague Shannon will reply to you directly. Okay, and so this morning, this webinar is focused on how we can leverage geospatial tools and data to accelerate clean cooking access globally, and we'll be deep diving into our development of the Clean Cooking Explorer, which is an online open source and interactive geospatial data platform being co-led by CCA and the World Resources Institute for the government of Nepal. And then we're hoping to expand into other countries as well. And so we're really excited to show you the power of this platform and more about how spatial data and tools can be used across the energy access sector. And so with that, I'm going to pass the mic to Dimitris Mentis, who is a senior energy geographer with the World Resources Institute. He's going to say a little bit more about the webinar and why this platform is so exciting.
Thank you very much, Alicia. Welcome, everyone. Really thrilled to be with you all today, even virtually. My name is Dimitris Mentis. I am a senior energy geographer with the World Resources Institute, the acting lead of the Energy Access Program. We at WRI believe that good data is really the foundation of actionable and transparent decision making. And as such, we've been long committed to producing platforms and analytical tools which can be used to provide data-driven insights to address 7 major challenges at the intersection of environment and human development. These challenges are around cities, climate, food, forests, the ocean, water, and energy. On energy, 3 years ago, the World Resources Institute initiated the development of the Energy Access Explorer, which is another open source geospatial platform focusing on the identification of high priority areas where access to energy should be expanded. Fast forward to today, we are collaborating with the Clean Cooking Alliance, APC, the KTH, Royal Institute of Technology in Sweden, Kartoza, the Nepal Open University, EasyMode, and others on the development of the Clean Cooking Explorer, which is essentially a sister platform to the Energy Access Explorer and can be used to identify high priority areas where the adoption of clean cooking technologies should be expanded. While we're prototyping the Clean Cooking Explorer for Nepal, our ambition, as Alicia mentioned earlier, is to expand the platform to include other geographies. Following remarks from APC, colleagues from CCA, Clean Cooking Alliance, KTH, and Kartoza will take us through the platform in more detail, and later on you will have the opportunity to share your questions with the team. Finally, colleagues from the Nepal Open University will provide closing remarks. With that, allow me to pass the mic to Dr. Adhikari from APC, who will be taking a little bit more about why the development of the Clean Cooking Explorer is so important and exciting for accelerating access to clean cooking in Nepal. Thank you.
Thank you very much, Dimitris, and Alicia and all the friends. Thank you for giving me this opportunity to speak a few words on the issue that we are working on. So every one of us are very clearly understood the need of promoting clean cooking solutions as a priority. By 2030. We aim to have clean cooking solutions to most of the people in the developing countries. So this is an initiative. Also, Nepal is joining with all the possible support from the knowledge, technology, models of promoting, financing all. So we are doing this from long time, but the time has come that we should do it in more organized and in more informed way. And then it's a lot of technical development has happened, and then we have a lot of IT support, GIS, information systems and all. So in that line, we have been working always with Clean Cooking Alliance here in Nepal for many years with IC more practical actions and other universities in Nepal. So when this Clean Cooking Alliance came with this proposal to develop the open source web-based platform to put all the possible information data, and then to use that as a knowledge to bring the right information at the right point of time. So in that line, this Explorer is, as I've also listened to the demo presentation a few days before, that basically capturing all the macroeconomic data that can be used for multiple permutation and combination to make our effort more result oriented by bringing all the information together. So where is the settlement, where are the people, where are the institute, where are the organizations, where are the market, where are the manufacturer, all these things, and what kind of solution people using. And in case of our contest, when we have these federal structures around 753 independent local level governments are putting their efforts to develop their small territory. So we are also in position to go to that level and even to the village level with the GIS map. So that would be fantastic to have such kind of tool that can be communicated very quickly and then documented as per the need. So it includes the data integrated with the GIS. And then we have these analysis part, which basically runs on queries. You want to develop your reports or information or knowledge in the form you like. So this is really a good tool, and we are also very timely that we are developing our country action plan on clean cooking. It will be a kind of program for the country to have the transition cooking from traditional to the modern energy access and the equipments. And also in the last board meeting of GCF also approved our project on clean cooking, which is designed to support 1 million households in 5 years' time. It's a quite ambitious project, 49.some million US dollar project. We already approved from the GCF board. So these all are very, very timely, and it's giving us a lot of informed decision making and a lot of knowledge from the international communities. That is very important for Nepal. So I would like to thank all the efforts put in to develop this, to all the partners where the Clean Cooking Alliance and all research institutes are leading in this. We are also part of it. Then we have this KTS University, Open University Nepal, and then these all are specialized. We are looking forward to host this platform in the case of Nepal, and I would also commit that we will try to manage it. Also discuss be some capacity development need in to know the system itself, but we are very much focused and geared up to move with the clean cooking solution transition. So will definitely use this and take the maximum benefit to make our decisions in the right way. AEPC is working very rigorously with our Ministry of Energy, and now the electricity access has reached almost to 95% of the population today. Right at this time also, I'm in a resort. All the top body from the Energy Ministry, including the minister and 5-6 secretaries, we are right now also discussing how to use electricity to increase the livelihood and replace our import, basically a fossil fuel. We import a lot of LPG and other stuff for cooking, even the charcoals and then coal. So these agenda in the top list of Nepalese government and policymakers. So all this support and the tools will be very, very useful for us. So I love to be hearing all, but as I mentioned, I have to, in the parallel session, joining our minister and secretaries in discussion. So I will be partially attending it. The Karunaji is very much familiar. We worked together for many years in APC. So she's a kind of all-informed person in this sector with the government rules and regulation policies. So definitely, but this will be a very, very big support to us, and we promise to keep it and run it in properly. Thank you all the efforts put in to develop this. Thank you all. Have a nice discussion. Thank you very much.
Thank you, Madhusudan. Okay, let's get started with the presentation today. So real quick, there's going to be 3 speakers throughout the presentation. Myself, Santiago from the World Resources Institute, and Camilo, who is with the Royal Institute of Technology at KTH. Okay, and I'd like to start off with a quick poll. I'm sure many of you know the answer to this question, but just setting the context a little bit. Approximately what percentage of the world's population relies on polluting open fires and inefficient fuels such as wood, charcoal, coal, and kerosene for cooking? So I will launch the poll and input your answer, please. Okay, wait, I'll give it a couple more seconds. It looks like some people are still answering. All right, so I will end the poll now since it looks like most have answered. So according to the World Health Organization, approximately 1/3 of the population, so around 35% actually rely on polluting cooking fuels and technologies to make meals. And so that's around 3 billion people, which is a large percentage of the population. Okay, all right. Next slide, please. Okay, so relying on polluting cooking fuels and technologies impacts pretty much all facets of life and really, really impedes economic and social development, especially in low and middle income countries. So in terms of health, household air pollution from using these polluting cooking fuels and technologies is actually the 2nd leading environmental risk factor for deaths worldwide. So up to 4 million people die prematurely every year from smoke-related illnesses. But health isn't the only thing that's impacted. So the smoke leaches into the atmosphere, and climate pollutants and gases lead to climate change as well as ambient air pollution. So the burning of solid fuels for household energy needs, so this also includes lighting, not only cooking, produces over 50% of global black carbon emissions. And black carbon is the 2nd largest contributor to climate change after carbon dioxide. And then other environmental impacts. So if you reliance on wood fuels contributes to forest degradation when it's harvested unsustainably. And then lastly, women and children are often disproportionately affected by all of these negative impacts. So they often have to spend hours gathering fuel. And according to the World Health Organization, can be anywhere from 4 to 20 hours per week. And if they're not collecting fuel, then they're spending a significant portion of their household income purchasing it. So really clean cooking is needed to ease the global health burden, but also reduce climate impacts, protect our natural resources, and empower women and advance gender equality. Next slide, please. And so the burden of using polluting cooking fuels and technologies is not borne equally across the world. So as you can see, this proportion of the population with reliance on polluting fuels and technologies occurs primarily in sub-Saharan Africa and then South Central Asia as well. And then even within countries, the burden can be super disparate. So for example, in some places, access rates to clean cooking technologies can be 10% in rural areas compared to like 70% in urban areas, just within a single country. And then something that I think is really astonishing is that 80% of those without access to clean cooking fuels are dispersed just across 21 countries. And then I would like to pass it to Santiago, who will introduce why geospatial data and tools are needed to scale clean cooking access.
Thank you, Alicia. Yeah, my name is Santiago Sinclair from the World Resources Institute. I'm a research analyst working in close collaboration with the CCE. And well, now that we have a better understanding of the reliance on polluting cooking fuels and technologies and the related impacts, we can ask ourselves, well, how can we enable and scale access to clean cooking solutions? And first, scaling, scaling access to clean cooking requires carrying out proper energy planning to match the supply with the growing demand in the most cost-effective way. In this, traditionally, energy planning has required a plethora of input data, parameters in order to solve optimization problems. And in order to keep models solvable in a reasonable time, most conventional energy planning tools consider spatially aggregated regions. However, the spatial dimension is important for planning access to clean cooking, and several data related to energy demand and supply comprise of geographic attributes. These include information related to the proximity to supply, such as energy resources in power infrastructure and how it varies in space, or also demand side factors such as the economic activities and the affordability and how it differs from one area to another. And so without geospatial information, these details which are essential in energy planning cannot be captured. The simplifications used by conventional energy planning tools call for a more integrated and granular solution. And here's where geospatial information is of key importance to help identify effective energy plans to scale access to clean cooking. So we need to consider examples such as the geographic characteristics of energy resources, spatial dimensions of the social and economic drivers of demand, as well as access to and availability of geospatial data and the establishment of programs to collect these where it's not available. With all this being said, what is geospatial information and GIS? GIS is a system that allows users to create, analyze, store, and visualize various types of data that have a spatial component. It connects data to a map. It integrates data on location, so where things are, with all sorts of descriptive information, or, for example, what things are like there. It helps people understand patterns, relationships, and geographic contexts. Among the various benefits, it includes better management and decision making. Now, coming back to the clean cooking, in the development of a clean cooking platform, we've identified that the sector will benefit from a tool that has three features. First of all, there's a need to treat demand and supply as equal. If we don't understand the demand from the bottom up, the supply strategies will not be viable, neither for the consumer nor for the suppliers themselves. So we need a platform that synthesizes granular data on both demand and supply while taking into account other criteria and constraints which are geospatial in nature. It is also essential to reduce reliance on GIS capacity and programming expertise. So users with limited or no GIS capacity should be able to develop custom, high-resolution geospatial analysis. And finally, that the platform deploys an open source dynamic information system to store and administer data and functions. So data providers need access to an open source GIS data repository to reduce some of these data transaction costs. So with that being said, we're excited to share with you all about the development of the Clean Cooking Explorer. The CCE will be an online, open source, interactive, and user-friendly spatial platform for promoting access to clean cooking and in Nepal and beyond. So the platform's development is a close partnership between Nepal's Alternative Energy Promotion Center, or AEPC, the Clean Cooking Alliance, World Resources Institute, Cartosa, Royal Institute of Technology, KTH, Nepal Open University, and EasyMode. And you can see all the organizations here listed in the diagram. But also CCE is being built in close collaboration with key stakeholders to ensure it is user-friendly and focused on the conceptually relevant priorities in Nepal and the world. So how will the CCE accelerate clean cooking access in Nepal and beyond? So users of the CCE will be able to customize the analysis and identify areas where access to clean cooking can be expanded based on their own perspectives. More specifically, the use of this platform will enable to support strategic decision-making and promote effective planning related to clean cooking options. So organizations and agencies can use the platform to identify areas where the uptake of clean cooking should be prioritized. It will also enable the expansion of clean cooking markets. So providers of clean cooking technologies can use the platform to better assess areas where their customers are likely to be and where there is potential concentration of demand. And finally, enable the data-driven coordination across all levels of government, functioning as a data repository and a one-stop platform for location-specific data. In this way, creating alignment across all levels of government and relevant stakeholders as well. So how does it work? We're building the CCE using an available open source adaptable web infrastructure from the Energy Access Explorer, EAE, CCE's sister platform. And thanks to the open source and adaptable nature of this structure, CCE will be built upon for Nepal and can be scaled further to include other geographies in the future with minimal resources and time. CCE will be designed as a modular tool that considers the multidimensionality of access to clean cooking. It synthesizes several spatial data sets on both energy demand and supply, as we can see in the diagram here. Demand and supply, let me just use the pointer there. And hosting different types of data at various resolutions, scales, and formats. So we can see the different data sets and categories within demand, supply, as well as different filters and other data sets that can be used from several other data sources. So with this approach, it allows the CCE to offer a multi-criteria analysis, bringing in several of these data sets accordingly. Okay, but thinking about it in practical terms now, CCE offers a multi-criteria geospatial analysis tool that allows to customize scenarios and identify high priority areas according to the user's perspective. And we can see here a snapshot of the platform itself and how it will look. And I will hand it over to Camilo now, who will show us some very exciting examples of these scenarios. Camilo, over to you.
Excellent. Thank you. Thank you, Santiago. So I'm Camilo Ramirez. I'm with KTH Royal Institute of Technology in Sweden. I'm a part of the team building the Clean Cooking Explorer. So I'm going to kind of walk us through some different sample scenarios and analysis that an user can do in the Clean Cooking Explorer. For this, we're going to take a look into a couple of scenarios from different perspectives, just to show how flexible and the platform can be, and that actually can help different stakeholders look in the problem of clean cooking from different perspectives. So for this first scenario, we're going to take the role of investors that want to expand clean cooking markets using a particular technology. So for this, the Clean Cooking Explorer supports a lot of investors by using demand side datasets, current supply, and assessing the availability to pay from the customer. So it makes use of several different geospatial datasets to highlight which would be the areas with high potential to expand easily these clean cooking markets. So for this particular scenario, we're going to focus on electricity. And we're going to take a look into different kinds of demands for cooking. So if we go to the next slide. Okay, so then now we're going to see some types of dataset that can be selected from the demand category. In this case, we are taking a look into the population density. Basically, this dataset will tell us kind of what's the spatial distribution of the population throughout the country. So basically, the higher the population it is, then the higher demand for cooking will be, of course. Then we can also select or overlay some other datasets as education facilities. So we can take a look in this as a productive use of clean cooking or cooking, right? So we can kind of combine these two and have a more holistic approach of understanding what's the demand. Similarly, we can add also health facilities to be able to assess also where would be the demand for clean cooking technologies in the health sector. And finally, in this scenario, we will also add the International Wealth Index. This index is a composite index that goes from 0 to 100. In the case of Nepal, it's around from 8 as a minimum value to 85 as maximum value. And basically, it kind of assesses the economic capacity or wealth of a household depending on the assets they own and the quality of housing. Basically, numbers, low numbers indicate low economic capacity, and high numbers indicate a high economic capacity. So this will be useful to assess which areas or which households could afford easily clean cooking solutions. So all of these data sets, the platform what does is that it takes all of these selections and it makes a normalization of the data, combines them, and categorizes the results into a clean cooking demand index. This index goes from low to high, and basically it tries to capture which are the areas that have, for example, in the low category, that have a low population density, that are far from education and health facilities, and have low economic possibilities to afford a clean solution. And the category in the high will be the opposite, right? So high population, closeness to educational facilities, closeness to health facilities, and they have a high international wealth index. So this analysis, as we see it here, will kind of help an investor to identify which are these hotspots of demand that where the markets can be easily expanded. But for example, in here, we are taking a look into the entire country. So something interesting that the platform provides, it's a way of filtering results and customizing them based on the needs of the stakeholders. In this case, we filter the dataset constraining the International Wealth Index to account only for areas that are over an index of 40 in the International Wealth Index. This basically tells us which are the areas that are on a higher economic capacity of affording these clean cooking solutions, in this case, electricity, as we're gonna see in the supply. So basically this kind of narrows down a lot more the results for an investor to be able to identify those areas. So now moving forward to the supply side, the platform works in a similar way. And basically we start overlaying or selecting which are the supply that we want to account for to be able to reach these goals of clean cooking access. So if and then we can select existing distribution lines. This is distribution lines of the electric network in Nepal. Then we can overlay also existing substations. And on a similar way, the platform calculates a clean cooking supply index. This index is based on proximity to the current infrastructure. So these two layers that were selected, and basically ranks from low to high, how close a region is from the current existing supply network. So in this case, electricity. And similarly to the demand index, the user can constrain or filter more the results. And in this case, we are using a 30-kilometer proximity to the network or to the supply network, so substations and distribution lines, to kind of disregard or be more realistic in the approach, as the current electricity network cannot reach everywhere in the country. So basically we only take into account which are those areas that are on a 30-kilometer radius of proximity. Then moving forward, the platform then takes both the demand and the supply index and combines them together. And if we move forward, then it calculates the clean cooking potential index. Basically, this is a composite index that combines the demand and supply that were selected, all of this information, and highlights which are the areas that have more potential or low potential, depending on all of these data sets that were selected and the constraints that the user put. So in this case, it is telling us which are those areas, for example, in the high category, that will be have potential to expand electric cooking markets based on high demand for population, closeness to health centers, closeness to educational facilities, which have good economic capacity, and which are also close to electricity supply network. Then if we move forward, we can also derive some useful statistics that will help the investor to assess the size of the market. And we can see, for example, what's the amount of the number of population that are within each category, so high, medium to high, and see how large the market is there. As well, we can see how many education facilities are within each category. and also health facilities. So all of these different statistics and numbers will help an investor to assess kind of the size of the market and see where to put their money and to try to expand these clean cooking solutions in the region. Now, in the next part, we're going to take a look at sort of the same scenario, very similar scenario, but from a different perspective. So right now, we're going to take a look or take the role of donors and policymakers. So right now, we are not that concerned about expanding or identifying the potential areas where clean cooking can be expanded easily, but kind of the opposite. So we want to identify those areas that are in most need of assistance. So areas which have low economic capacity or have unavailable supply, but still they have a large supply. So in this case, we're not use the same data sets in the demand side. So population, health facilities, and then education facilities. And also the wealth index. But in this case, the wealth index, we're gonna take a look or prioritize areas that are under wealth index below 40. So the poorer areas that will be in most need for help from donors and policymakers to be able to get access to this clean cooking solution of electric cooking. So if we move forward, then the supply index will be also kind of the same as before. So we select the distribution networks, we select the substations, and we constrain it again to 30 kilometers because we still want electricity to be in reach, so to be able to provide electricity to these users. Then the platform combines these two, the demand and the supply indexes, and it produces the, if we will move to the next slide, it produces, now we take a look into the need for assistance index. So yeah, exactly, so need for assistance index. This index keeps kind of the other part of the story, kind of posed as the clean cooking potential index. So this index basically prioritizes areas with a high category, areas that have still high demand for cooking, that are kind of not, are far from the supply or not that close to supply, and the economic capacity is low. So these areas that are in most need of assistance from donors and policymakers to be able to access these clean cooking solutions. And in a similar way, we can produce the same statistics and derive which are the amount of population within the different categories, which are the number of education facilities and the number of health facilities. And this also will help donors and policymakers to assess what's the size of the problem and what's the kind of the amount of efforts and financial assistance that they will need to put to be able to help these people transition to clean cooking solutions. Then is this to say that the Clean Cooking Explorer is much more than this. It will have several other use cases with different supply technologies and filters to select. So basically, it allows for a lot of flexibility and will allow the user to really make a custom-made analysis. So for example, supporting low-income areas with the use of biogas. So in this case, we select population density, then we can also use the wealth index to identify those low-income areas. Then we add the map of potential of biogas, so potential of biogas production. This one has been produced using livestock information. And then we can assess what's the clean cooking potential index and identify those areas where biogas can have a role and be used to transition to clean cooking. Then also, for example, we can take a look into LPG markets and try to see how LPG can be expanded or how can aid in the story and in the problem. So in here, for example, we are taking a look only into productive uses, so health and education. And then we just add information about the supply network of LPG, so roads and supply points of LPG. We constrain it to some distance of reach as well. And then we end up with an index that is highly customized for this particular scenario, showing those different areas that have a high potential to be supplied with LPG. So these are just some other couple of examples, but as I mentioned, the platform is highly flexible and will allow the user to make a custom-made analysis and explore the questions that they want to explore. Also, in here, we presented all analysis on the national level, but it's important to say that the platform will also allow to make all of these type of analysis on a subnational level. So to select a particular province or district even, and see the particular results and values and statistics to that particular region, which a person is interested in. Okay, thank you. That was kind of the scenarios that I wanted to guide everyone through, and now I pass it to my colleague Alicia.
Alicia, you're muted.
Sorry about that, I was muted. Hi everyone, so now we have around 20 to 25 minutes to take all of your questions. So if you have questions, you can just input them into the Q&A tool and I will get to them. I see we already have a couple questions. So we'll start with the first one that I haven't answered via chat. This question comes from Roger. To what extent does the grid network capacity, to what extent is the grid network capacity captured? I think that would likely be a question for the KTH team.
Okay, so if I understand well the question, the grid network capacity accounts for kind of the current capacity. So how much the grid can currently take more additional capacity from clean cooking or from electric cooking, sorry. So in this specific analysis, we are mainly taking into account only proximity to the supply network. So the current capacity is not really included in the analysis so far. However, as the platform is highly flexible and let's say it can be updated on a constant basis, new data sets could be uploaded, for example, a dataset that could account for these capacity constraints. And then kind of adding this new capacity, that will be a new layer to the analysis and can somehow try to filter the results and make a more thorough analysis.
Okay, great. This next question asks, what kind of data sets are you using for LPG and how do you take into account the function of biomass reserves in the country? So I think that would be a question for NOU or KTH, whoever wants to take it.
Maybe if NOU can talk a little bit about the LPG supply and we can take a little bit on biogas.
Okay, so on the LPG side, I'll take questions and as you told, the later half you may answer later. So right now we are considering the depots, the network of the LPG suppliers and the refill stations of the LPG gases into account. So that particular geolocation is taken, and that will be then later converted in terms of cost to travel and other models that just was explained earlier. So if I understand the question correctly, so we just collect those geographical points from where LPGs are sold out and refilled. These two types of data sets are collected. For the biomass again, Camilo?
Yes, thank you, Roger. So for biomass, we have some data sets that we have produced, for example, on canopy coverage of forestry in the country that we are using also to assess what are, for example, the travel times to the different resources in biomass. So how long, for example, a person will have to travel to access to these resources. So all of these data sets can be used as filters as well to incorporate into the analysis. And we are also working into trying to get some data on forest kind of sustainability of forest. So how the forest is I say like the amount of forestry that has been explored this, and if this forest has been explored in a sustainable way. This is still not there in the platform, but there are plans to account for this type of data sets that will also add another layer to the analysis.
Okay, and then the next question is, does the spatial distribution of the population substitute for households? And Camilo, maybe?
Yes, that can be said. So basically, it goes really in hand with the distribution of households, and all of these data sets are produced kind of in that way, accounting for the different. So the higher the density, the higher the household that are going to be in that region as well.
Okay, and the next question is the Clean Cooking Explorer free to use for all countries. So the Clean Cooking Explorer is open source, which means that it is free to use, and also the source code is readily available and linked in the platform. However, right now the Explorer is being developed for Nepal, but we are planning to expand to other countries in the future. And I think there was a question related to this that asked if we were using Esri software to develop the platform, and the answer is no, because the platform is open source. And I don't know if Camilo or someone from WRI would like to go into more detail about what software we are using to develop the platform.
It's probably one for me to answer. Hi, this is Tim speaking. Yes, so the platform is built using GeoNode, which is an open source geospatial content management system. And that itself is built on top of something called Django, which is Python-based programming library for building web applications. And then there is the Energy Access Explorer code is integrated into the platform as well, which is the software that has been developed by WRI as part of the Energy Access Explorer toolkit as well.
Thank you, Tim. Thank you. Okay, so the next question is, for demand side, what data have you used for cooking energy status of each municipality? Do you have updated data for all municipalities? Sorry, the question disappeared. Okay. I don't know if Camilo, that's a question for you again.
Yeah, that's okay. So in the current status, on the municipal level, the most up-to-date data that we have right now is the 2011 census, which is already a bit dated. So what we have in the platform right now is the DHS survey, which is 2016 and 17, but this one is on a provincial level, so it's not as high resolution as the 2011 census. However, a new census is currently being developed in Nepal, so this data we are expecting to be updated in the near future.
Below, I would like to add to it, apart from the demographics data, all the data are updated, like the electric lines, station, substation, all of them are again updated to the latest 2021 report of Nepal Electric Authority. So we can say that apart from the this demographic data that is based in 2011, all the data are almost must updated even in the municipal level.
Okay, and then the next question is, can the analysis be performed at city level? I don't know if Tim or Camilo, you'd like to talk more about the spatial resolution of the analyses.
Maybe I'll just take that one. So yes, on the platform as we're deploying it now, we're working with 1 kilometer standard resolution for datasets, but that's just our own convention for Nepal, but it can be used at any spatial scale. So it just really depends on the resolution of the data that you have available, whether it's suitable to be used at city level or not.
Okay, next question is, what information is in the system about woody biomass supply? I believe that Camilo has already talked about this, but I don't know if you want to go into more detail about the data sets that we do have.
That's okay. So yeah, currently we only have canopy coverage. So that's basically spatial data that have been produced with geospatial imaginary, trying to identify what's the coverage of tree forest. So basically, it tells you from 0 to 100 what's the percentage of coverage of trees in every particular cell. And based on this population layer, we also have produced some travel time datasets, as I mentioned before. These are what we have right now, but as I mentioned, we are planning to add a little bit more on biomass as well.
Okay, we have a question. How do we plan distribution and supply for both ethanol and clean cooking stoves? Well, I don't know if Bob, you would like to rephrase this question. I'm not quite sure I understand the question. The Clean Cooking Explorer can consider multiple different clean cooking technologies. And so you could select whatever clean cooking technologies you want the tool to consider at the same time. But I'm not sure if that's what your question is asking. Okay. And then are there any other questions? That was the last question. I believe we've answered all of the rest of them. So if there are any more, please feel free to type them in the Q&A.
There was a question about how you get access to the software. I've shared the link to the repository, which is where the source code lives. It's in the chat. But just please note that we're still in the final build out stages of the platform. So we expect to have version 1 available at the end of November this year. But everybody's welcome to go and look at the repository. It's all been developed completely in the open. So feel free to have a look there and engage with us through the repository if you like.
Okay, and then we have a question saying, please provide an email address of a technical person about the software. So I'll be sending out the slides after the webinar, and on the speaker slide, you have our email addresses. You can feel free to reach out to any of us about the Clean Cooking Explorer there. Okay, does the Clean Cooking Explorer platform include improved biomass stoves in its analysis of cooking services? So currently, no, it only considers clean cooking technologies at the moment. But I think that we are in discussion about potentially extending it to improved cook stoves as well. Okay. And then, okay, Tim, did you say you put the link to the source code in the chat?
Yes, and by that I meant in the Q&A, sorry. And so I did respond also to that one. So if you look in the Q&A, there was a previous question about where can we get the source code.
Okay. And then, okay, please send me the contact of the presenter. Okay, so for Bob, my email address is in the speaker slide, and I'll be sending the slides after the webinar, so you'll have my email there. Okay, are there any other questions? Okay. And then if you'd like to see the answers to any of the questions that we typed, you can use the Q&A feature and see the answered questions as well. Okay, but if there are no further questions. Okay, well then, if there are no further questions, I'd like to thank everyone so much for attending. I'm going to pass it to my colleague, Dr. Bose. He is representing Nepal Open University, who we have the pleasure of working with, and they've really been leading the data collection and on the ground efforts in Nepal. We're incredibly grateful for them.
Good morning, good afternoon, and good evening to all who could make it today. I'm Dr. Bose, working in Nepal Open University. So after almost a year of hard work on the data assessment, partnership consultation, data collections, platform development, module training, rigorous feedback on the system, we have come to this round today. It's thanks to Katuza, Isimod, KTS, WRI, CCA, APC, and many and my colleagues at NOU who 24 has brought us to this stage here. However, there are many others, including NEA, VDOC, WINDOC, GIZ, WWF, and many other more national and international organizations, including all of you present today, whose contribution cannot be neglected and cannot be forgotten for the development of the system. Technically speaking, platform development is very crucial, but what's more important is addressing user needs and embedding this tool in their standard operating procedure of the users, organizations, and keep this running, improving in every iteration, making it more useful. So another very important aspect is the sustainability of the tool. For that, we see three aspects. First, technical strength of the host. Second, continuous data feed. And third one, improvement and upgrade of the system to cater dynamic need of the users. So if we talk about Nepal, as discussed during our sessions, we plan to empower AEPC, Alternative Energy Promotion Center, to take a lead on the first two, that is technical strength and continuous data feed. And Nepal Open University will always be there as a local partner to provide any ground support needed, including concept development and others. We wish, with the support from the Alliance, KTS and Katuza will be continuously working on number 3, that is improvement and upgradation of the system. And since it's a free and open source, the independent developers can work on adding the modules into it on their own. So I'd like to take this opportunity to thank all of you who have contributed directly or indirectly during our journey so far. Thank you, Dr. Adhikari from AEPC, for your commitment and willingness to host the system. I'm sure Nepal and other implementing organizations will be able to harness the strength of this geospatial tool for better planning and their energy investment and related decisions. Now, let's work together to make this tool really useful to support the campaign and reach the targeted, stated target of clean cooking people, whatever population we fix in our individual country. Thank you all, and that's it for today. Thanks, Elsie.